Hi everyone, it's Mrs. Zimmerman and Mrs. Kautsoulis. We're here to teach you more math again. So hopefully, yay, we're excited too. So hopefully you just watched the video of me doing a little bit of review on coordinate graphing, and now Mrs. K is going to show us a little bit about reflections, kind of some new stuff that you haven't seen with coordinate graphs before. So it's going to be pretty good. Mrs. K, so whenever you're ready, go ahead.
Okay. So I'm going to pull this up so you can see this. So one of the things that Mrs. Zimmerman just mentioned was reflection. And remember, reflection is when the image is mirrored, or you flip it. And another word for flip is rotation. You may have talked about that or been exposed to that in elementary school, but you can see this tree is being reflected, or it's flipped on the ground there, the horizon. And it's flipped how? It's flipped down. So we can see the image of the tree in the water. All right, so that's what we're going to do with points today. We are going to reflect points. Now, Mrs. K drew a graph here. If I can get myself back here. There I am. I drew a graph. I'll make sure I come back far enough. But this is my coordinate graph. And if you remember, Mrs. Zimmerman just visited with you about quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, using Roman numerals again from your Rome unit in social studies. And I use the school colors, red for my x-axis. Remember, that's always horizontal, that never changes. And my y-axis is my black x-axis, and it always goes vertically. And so what we're going to do is we're going to reflect today points from one quadrant to another. So I'm going to draw a point on this coordinate graph. And let's see, I want to go right here. This looks like a good spot. So I drew a point in quadrant 1, right up here. All right. Now I have a choice. I can reflect it over the x-axis, or I can reflect it over the y-axis. When it reflects over the x-axis, I'm going to fold my coordinate graph so that this point now is down in the bottom quadrant. And I'm going to show you that by drawing it on my paper. It's got to match. All right. So here I have the point that I started with, and then the point that was reflected. So I'm reflecting this point over the x-axis, and its reflection lands here. Now, Mrs. Zimmerman, what quadrant did my reflected point end in?
It ended in quadrant 4.
Right. So it flipped this way. It's just a flip. So if I fold that over, it matches my point that I started with. It's just a flip, or we call it in math a reflection. Now it can also reflect over the y-axis, but I want to throw another point in here today. So I'm going to throw a point in here, and this time I'm going to use black so you know it's my new point. All right, so here's my new point. I decided to put something in quadrant 3, so I didn't have anything there yet. So here's my new point, and I want to reflect it over the y-axis. So this is the y-axis. That's the place I fold my paper on so you can see that it's being reflected. And my point is going to be reflected on that opposite quadrant. So I'm going to draw that point so you can see that at home. All right. So now you can see this is the point that I started with here, and it reflected over the y-axis to my other quadrant. Now, when we reflect, remember we have to figure out which, or we have to read very carefully to know which axis we're folding over, we're reflecting over. This is always the x-axis, and this is always the y. All right. Now, let's look at Mrs. K's slides. So I'm going to share my slide with you here. All right. And so it says reflect point A in the x-axis. So here is point A. This is its ordered pair that tells me the location. I am -3 on the x and 2 on the y. And I want to reflect it over the x-axis. So the x-axis is this line right here. I'm going to get my pointer to help you see a little bit better. So this is my x-axis. So that means I'm going to fold on this line, class. So that means that this point is going to end up in this quadrant. Now, the easiest way to do that on graph paper is to just count how many I am away from that x-axis. So I am 1, 2 away from that. So I'm also going to go 1, 2 from the x-axis in the opposite direction. And so my point lands there, and my new ordered pair, my new ordered pair is -3, -2. I'll show you what I have here. A -3 on the x-axis and a -2 on the y-axis. Now, the next thing says that I need to find the distance between the two ordered pairs. Well, it's easy when you have graph paper because you can just count 1, 2, 3, 4. But there is also a way to do that mathematically. And what you do is you take the opposite coordinates of the axis you folded over. So I folded over the x-axis, so I'm going to look at my y coordinates. Remember, in an ordered pair, in an ordered pair, this is my x and this is my y. This is my x, this is my y. So because I folded over or reflected over the x-axis, I'm going to look at the y coordinates and I'm going to add them. And if I have a negative number, I have to change that to the absolute value. So here I have the 2 from this ordered pair, and I'm adding the 2 from this ordered pair, which is really a -2. And remember, if I have a -2, I'm going to find the absolute value of it. So 2 comes down plus, we're going to solve or evaluate this expression. The absolute value of a -2 is 2 because it's 2 away from the 0. 2 away from 0 on the number line. So 2 plus 2 equals 4. And so we are 4 units away from A and its reflected point. All right, let's go to the next slide. So Mrs. Zimmerman, it says that we're going to reflect -9 and 5 on the x-axis. So which axis am I going to fold over or reflect on?
The x-axis is the horizontal line.
Okay, so I'm going to reflect this point over that line. And the easiest way on graph paper is just to count. So I'm going to count 1, 2, 3, 4, 5. I am 5 away from the x-axis. So now I'm going to do the same thing on the opposite quadrant. So 1, 2, 3, 4, 5. So my point goes right there. If it'll do it, there we go. And if I want to write the ordered pair, I count -9 on my x-axis and -5 on my y-axis. So my ordered pair is -9, -5. Easy. Just make sure you flip it or reflect it over the right axis. You have to read carefully. Now it says find the distance between the two ordered pairs. Well, again, I flipped over the x-axis, so I now have to add the y coordinates. The y here is 5, and the y here is a -5. But when it's negative, remember we have to write the absolute value of that. So I have 5 plus the absolute value of a -5. And -5, the absolute value of it, is 5 away from 0. So we're going to write 5 plus 5, and 5 plus 5 is 10. So we would say this is 10 units from this point to this point. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, bingo. We figured it out by looking at the coordinate graph, and we figured it out by using math to get that. Mrs. Zimmerman, do you have anything you want to add?
I don't think so. The only thing is just to remember, if you're reflecting over the x, then the values that you add are the y in your ordered pair. I think that would be the key thing to remember for you guys. But otherwise, I think we're good.
Okay, let's try it on this one then. It says reflect -5, 2 on the y-axis. So now, class, we are flipping it over this line. This is our y-axis. So if I flip this or fold this paper, this point's going to end up somewhere over here in quadrant 1. So I'm just going to count on this line, and notice I'm going to stay on the same line. 1, 2, 3, 4, 5. So now I'm going to move 5 on this side. 1, 2, 3, 4, 5. I'm going to plot my point, and I'm going to figure out my ordered pair. I went on the x-axis, a +5, and up on the y-axis, 2. So my ordered pair is 5, 2. If I'm finding the distance between the two ordered pairs, Mrs. Zimmerman just reminded you, you are going to use the coordinate that is different from the axis. I used the y-axis, so I am going to use the x values. I'm going to add this 5, which is x, plus the absolute value of this -5. And I have my work shown over here. The absolute value of -5 is 5, and 5 plus 5 equals 10. Let's check our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Class, we are 10 units between those 2 points. All right, I think this is our last one. It says reflect point B on the y-axis. Now, Mrs. K has these other values, these other points on the coordinate graph. Just ignore those. You are going to reflect only point B, and it needs to be on the y-axis. So that means if I fold this paper, B is going to end up somewhere over here in quadrant 2. So let's try it mathematically first. Oh, actually, no, let's count. we're going to count from B to the number line. How many units is that? That's 1. So we're going to move 1 on this side. And so my point ends up right here. And my ordered pair, I'm starting at 0. I'm going left, -1. That's on the x-axis. So that's my first coordinate of the ordered pair. And then I'm going to go 1, 2, 3 up. So my ordered pair should be -1, 3. Now we'll do it mathematically. I am going to look at the x values because I flipped over the y-axis. So we are adding 1 and the absolute value of -1. And 1 carries down along with the plus sign, and the absolute value of -1, which means that's the distance away from 0, is 1. And you add those two together and you get 2 units. If you look here, we are 1, 2 units away. So class, when you're doing reflecting, make sure that you're checking which axis you reflect over. Count carefully so you don't make a careless error. And then if you're finding the distance, the easiest thing is to just look at the coordinate graph and count. Like this problem, 1, 2. But if you don't have a coordinate graph there and someone gives you just 2 ordered pairs, then you can use this mathematical way to do it. Or I don't think Mrs. Zimmerman and I would be opposed to you graphing it and then figuring it out.
No way.
We're just trying to show you 2 different ways to find the distance between 2 ordered pairs. Mrs. Zimmerman, anything you'd like to add?
No, I think you covered it all, Mrs. K.
Just remember, when an image is reflected, it's like looking in a mirror. When you look in the mirror, your image or your face is being reflected in the mirror. Ta-ta for now.
See you
Good
next
luck.
week.
Move on to your next assignment. Thanks, guys.
Yeah, bye-bye.